Hello everyone, in this video we will be discussing about contours in OpenCV. In this video, we will learn about how to find and draw contours and the implementation of various handy features and functions of contours. Now talking about contours, what are contours? A contour is a curve which goes along the border of an object. Speaking in technical terms, a contour is a curve that fits all the points along the boundary that have same values or same intensities. Now, don't confuse contours with edges, as edges just check if there is any difference between neighboring pixels. Contours are somewhat similar too, but they need to be closed curves like a boundary to an object. If you can see in the image, the cards are clearly marked with a boundary curve. Those are contours. Contours are used in many fields of engineering, like it can be used to gain valuable information about the nature of terrain, in topographic maps to determine elevations, to find area, perimeter of an object, and to measure application in functions like shape analysis, object detection, and recognition. Now let's move forward in learning how to find contours. Contours can be found with better accuracy if you are using binary images. The reason being, binary images clearly increases the contrast between background and object by making object look white and background completely black. We will be using OpenCV library for finding contours as it has very handy methods to deal with contour. We can easily convert our given image to binary by first grayscaling our image by using convert color method of OpenCV and then applying threshold by OpenCV's threshold method. You can see how the image looks in the binary form and how clearly background is contrasted with the tomato given here. Now the syntax for finding contours is simply using find contours method of OpenCV as shown here. The contours variable here will hold a list of x and y coordinates of contour points. Find contours take arguments as source image, contour retrieval method, and lastly contour approximation method. We found the contour points. Now it's time to visualize it using OpenCV's draw contours function. It takes arguments as source image, list of contours which we acquired earlier, index of contours, and the remaining arguments are RGB color, thickness, etc. If we want to draw all contours, we pass -1 in the index argument. You can see the outcomes of using draw contours on the tomato image previously used. Now lastly coming to contour approximation method, which is the third argument of find contours function, is used to tell how many points to store in our contours list. cv.chainApproxNum stores all the boundary points, but we don't always need all the contour points available. For example, for a straight line, only the first and last point is enough to convey the information, and the points in between are just redundant data. That's where cv.chainApprox comes in handy. What it does is simply stores only important points like edges, saving a lot of memory in the process.
So let's talk about the counter features. The first features that comes is the moments. It gives the mass of the object, area of the objects, and it also gives some useful data like the area and centroid. Its function is cv.moments. Now let's talk about the another function that is the counter area. It gives the area of the counter image that and its function is cv.counter area. Now let's talk about the another feature that is the perimeter. Perimeter also called the arc length. It gives it gives the perimeter of the given function, and its function is cv.arc length. Now let's talk about another feature that is the contour approximation. It gives the approximation of an image, and we can see that its function is cv.approx polydb. So we can see there are there is an image with three figures in it. The first figure is white, and in the second there is some area is selected, some approximate area is selected where the image is, and third there image approximation is the approximate area of that image is also selected. So this is a function of the counter approximation. Now let's talk about the convex L. It's somehow similar to the counter approximation, uh, and they both may give the same result. So also, but they have some different functionalities. So its function is cv.convex hull. So we can check it though in the programming language. So now let's talk about the next feature, that is the convexity. It gives whether the feature is having a curve or not. Its function is cv dot is counter convex. If the image is having a curve, then it will return true, otherwise it will return false. Now the another feature is the bounding rectangles. There are two types of bounding rectangles. One is the straight bounding rectangle and another is the rotated rectangle. The straight bounding rectangles draws a rectangle with some minimum area, but rotated rectangle needs 4 corners for the rectangle. So the function for the straight bounding rectangle is cv dot rectangle, and for the rotated rectangle it's cv dot draw counter. And in the image and in the box, the center and the width, height and the angle of the rotation that where we wanted. So now let's talk about the another feature, that is the minimum enclosing circle. It encircles the whole image in a circle. Now talking about the next feature, that is fitting an ellipse. It fits the image into an ellipse. Now let's talk about the last feature, that is the fitting a line. It fits a line into an image.
Let us now discuss some other important properties of contour. First of them being aspect ratio. So aspect ratio is defined as the ratio of image width and image height. It can be found out using the dimension of bounding rectangle and then calculating aspect ratio by dividing the width by height. An aspect ratio of greater than 1 means that the image is in landscape mode, whereas that less than 1 means that the image is in portrait mode. Second important property is extent. Extent by definition is defined as the ratio of shape area and bounding box area. So it's always less than 1, as the bounding box area is always greater than the shape area. For finding the extent value, we can use the following code by finding the contour area and then the area of the bounding rectangle and then dividing the two. The third important feature or property is solidity. So solidity by definition is defined as the ratio of contour area and convex hull area. It again is always less than 1, as the convex hull area is always greater than the contour area. Following is the lines of code that we can use in order to find solidity. So we can find the convex hull area and then the contour area and then divide the two to find the ratio. The fourth important property is equivalent diameter. So if our current contour were a circle, then the diameter of that circle would be the equivalent diameter. We find the equivalent diameter by finding the area of the contour and then using that to find the diameter like we've done in the code. Fifth important property is the orientation. So orientation is actually the angle at which the object is directed. Using the fit ellipse function, we can find the angle of orientation as well as the major and minor axis of the ellipse which bounds the object in the image. The sixth important property is mask and pixel points. So sometimes it becomes important that we locate the pixels which belong to a particular object in an image. For doing so, we can use a mask and find the non-zero values of pixels in that mask. The seventh important property is finding the maximum and the minimum values with their respective locations in the image. So it is possible to find the values of maximum minimum values in the image using min-max-log method. The method gives 4 values, that is minimum value and maximum value, with their respective locations in the image. The 8th important property could be finding the mean intensity or mean color. So it's also possible to find the average intensity of the object in a grayscale mode using the following line of code, finding the mean. The 9th important property could be finding the extreme points in the image. So these extreme points could be leftmost, rightmost, and topmost and bottommost point out of the image, which could be found using the following lines of code. Here we have shown in the map of India the topmost, the bottommost, the leftmost, and the rightmost point.